All right, in this video we're looking at our 9A test review. We are going to be graphing quadratics, going from standard form and rewriting in Vertex form, and then identifying these attributes as well as graphing it. So I showed you guys a couple different ways in class how to rewrite these using standard to Vertex form. So I'm going to show you both ways here. The first way I showed you is if we move our y equals to the other side, we also need to move our constant of 13 to the other side, so we'll subtract 13. So we've got x squared plus 8x. There's our blank space. And on the right side, we've got a y minus 13. And he also needs a blank space. Since I don't have a coefficient in front of my x squared, I have a 1 here, I'm good to go ahead and fill in the blank. So there's 2 steps to filling in the blank. Take half of 8, which is 4, and then square that. 4 squared is positive 16. And so when you have your blanks are on opposite sides of the equation, if I have a positive 16 on the left, I'm going to put a positive 16 on the right as well. Got to keep it balanced. All right, so now I'm going to go ahead and come down here and rewrite this. So I'm going to factor this left-hand side, and I'm going to go ahead and use the shortcut. So I've got an x, and half of positive 8 was positive 4. So it goes there. And then on the right side, I've got a y, and when I combine these like terms, negative 13 plus 16, that's positive 3. And finally, to get the y by itself, I'm going to have to subtract the 3. So I'll come to the other side and subtract the 3, and I always just want to put that at the end. So I've got y equals, I've got my x plus 4 squared minus 3. Okay, the vertex is always a coordinate, so the x value is always opposite of what the x says. So negative 4, and this one is what it says it is, negative 3. Axis of symmetry, always x equals the x value of my vertex, x equals negative 4. So to plot these coordinates on the graph, my vertex is negative 4, negative 3. So we'll plot that coordinate. All right, now I need to know exactly where the rest of the coordinates go. Remember, I need to use my parent function table. Negative 2, negative 1, 0, 1, and 2. 4, 1, 0, 1, and 4. All right, and so what I'm going to do is I'm going to multiply. I'm going to multiply my a value times all of my original y values. Well, here my a value is a 1. So if I multiply all these original y values by 1, it's not going to change anything. 4 times 1 is still 4. 1 times 1 is still 1. 0 times 1. 1 times 1. 4 times 1. Okay, so that's not going to change. So I always start on my vertex. Okay, so I'm going to go, the x value is negative 2, so that means I'm going left 2. The y value is 4, so I'm going up 4. So I'm going to go left 2, 2, 3, up 4. Make sure you're going the right amount. These are half spaces here. Negative 1, positive 1, so I'm going left 1, up 1. 0, 0, that's the vertex. 1, 1, so we're going to go right 1, up 1. And then right 2, up 4. Positive 2, positive 4. And there is my first parabola. Okay. All right, so the second problem, I'm going to do it the other way I showed you guys in class. If we leave our y equals on the left side, negative 3x squared minus 18x, put your blank there. Move your constant minus 25 to the back, but he's also going to need a blank. Okay, so I cannot fill in this blank because I've got a negative 3 in front of my x squared. I've got to take out that GCF of negative 3, then you need to tell me what's left over. So negative 3 divided by negative 3, that's a positive 1, x squared left over. Negative 18 divided by negative 3, positive 6, x left over. Then you have your blank, then at the end you have your minus 25 with another blank. Excuse me. So now we're ready to fill in the blank. Okay, since I have a 1 in front of my x squared. So 2 steps, half of 6, which is 3, and when you square that, you get 9. Okay, now that's not what goes on the right side. 9 times negative 3, you got to multiply these. 9 times negative 3 is negative 27. Okay, which means the other blank needs to be a positive 27 on the right-hand side. So I'm going to come down here and I'm going to rewrite this. I've got the GCF of negative 3, he stays out front. I'm going to factor this parenthesis using my shortcut. Half of 6 was positive 3. And then at the end, when I combine these like terms, negative 25 plus 27, positive 2. So there's my vertex form. Okay, the vertex is opposite of the x value, so negative 3. And this y value at the end is what it says it is, positive 2. Okay, so negative 3, positive 2. Negative 3, positive 2. Oh, axis of symmetry, always x equals. The x value of my vertex here is negative 3. Alright, so again, my original parent function table, negative 2, negative 1, 0, 1, 2, 4, 1, 0, 1, 4. Alright, so again, we are multiplying these original y values by my a value. Here my a value is a negative 3. So we're multiplying all these guys here by negative 3. And I'm going to get new y values. 4 times negative 3, negative 12. 1 times negative 3, negative 3. 0 times negative 3 is still 0. 1 times negative 3, negative 3. 4 times negative 3, negative 12. Alright, so here we go. From the vertex, I'm going to go negative 2 on the x, so left 2, and I'm going to go negative 12 on the y, down 12. Left 2, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Left 2, down 12. I am also going to go left 1, down 3. Left 1, 1, 2, down 3. 0, 0, that's the vertex, ignore that one. So then I'm going to go right 1 and down 3. Down 2, 3. Okay, should be a mirror image on both sides. And I'm going to go right 2 and down 12. 1, 2, down 12. I know it should end up right here because it's a mirror image. Should end up on the same line as the first one. Okay, there's the second graph. Alright, so since 2 of my classes preferred this way of writing it in vertex form, I'll do that again here. So we've got 2x squared minus 4x, put your blank there, move your minus 2 to the back, and he needs a blank back there as well. I cannot fill in the blank yet. I've got to take out the GCF of 2. So be careful when you're telling me what's left over. 2 divided by 2 leaves me with 1x squared. Negative 4 divided by 2 leaves me with negative 2x. Then there's my blank. Now I can fill in the blank. Half of negative 2 is negative 1. When I square that, negative 1 times negative 1 is positive 1. 1 times 2 is 2. So this has to be a negative 2. The other blank is the opposite, negative 2. So let's continue down here. I've got a GCF of 2 out front. Now I'm going to factor this trinomial. I got an x. I need a squared. Half of negative 2 was negative 1. And then when I combine these like terms, negative 2 minus 2 more gives us negative 4. 2x minus 1 squared minus 4. The vertex, positive 1, negative 4. Axis of symmetry, x equals positive 1. So the vertex, positive 1, negative 4 is going to be right here. Again, when we graph those, plot those original parent function coordinates, we multiply the y values times my a, which in this case a is a 2. So all these y's get multiplied by 2. 4 times 2 is 8. 1 times 2 is 2. 0 times 2. 1 times 2. 4 times 2. So my new coordinates, left 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. Left 1, up 2. Left 1, up 2. 0, 0 is the vertex. Right 1, up 2. And then right 2, up 8. Up 2, up 8. And there's that one.